All right, let's talk about something that sounds like it's straight out of a sci-fi movie. A future where medicine isn't this, broad spectrum thing, but a super precise strike delivered by tiny microscopic magnets. And the craziest part? It's not science fiction. In this explainer, we're going to break down how this incredible tech is already here, and honestly, it's about to completely change how we even think about medical treatment.
So let's start with one of the biggest, toughest problems in all of medicine. Think about it. How do you possibly attack just one single rogue cell, say a cancer cell, without causing a ton of collateral damage to all the perfectly healthy cells right next to it? I mean, how do you pull off that kind of microscopic precision strike deep inside the human body? It's a huge challenge.
Well, the answer, it turns out, is taking us to a whole new medical frontier. See, to solve a problem this small, the solution can't just be small. No, it has to operate on a scale that's, well, it's almost impossible to even wrap your head around. We're talking about going nano.
And here's the hero of our story, iron oxide nanoparticles. Now, when I say nano, I mean it. These things are unbelievably tiny. We're talking thousands of times smaller than the width of a single human hair. And these little particles, they are the absolute key to unlocking this whole new era of precision medicine.
Okay, but what makes these nanoparticles so special? It's not just that they're tiny. Nope, they have this really unique property. You could seriously call it a superpower. And it's this superpower that makes them the perfect little agents for these incredibly delicate medical missions. And that superpower? It's called superparamagnetism. It's a pretty wild form of magnetism that really only shows up at this tiny nanoscale level. But here's the absolute key thing to remember. These nanoparticles are only magnetic when we tell them to be, when we want them to be.
The best way to think about it is like this. These nanoparticles are basically the perfect little magnetic on-off switch. You can flip them on when you need that magnetic pull, and then you just flip them right back off when you don't. And that control, that right there is everything.
So this superpower really has two key parts. First, when you flip that switch to on, by bringing a magnet nearby, the particles have something called high magnetic susceptibility. All that means is they get pulled really strongly towards that magnet. But then, and this is the second part, the moment you take that magnet away, poof, they have zero permanent magnetization. They just stop being magnetic, instantly.
And this is maybe the most important piece of the puzzle, and I'm pulling this right from the source material. They show no permanent magnetization without an external magnetic field. That off state is so crucial. Why? Because it means they're not going to just clump together and cause, dangerous blockages inside your body once their mission is over.
Okay, so we've got this incredible magnetic on-off switch. That's the science. But how do we actually use it to solve that big medical problem we talked about at the beginning? Well, let's take a look at how this whole thing is put into practice. This special property opens the door for two huge applications in what's called nanomedicine, which is really just medicine that works on a tiny molecular scale. First, it helps create way more advanced and clearer MRI scans. And second, and this is the one we're really going to dig into, is something called targeted drug delivery. Yeah, this is where it all clicks into place. Targeted drug delivery is really the ultimate application of that precision on-off switch we've been talking about. It basically turns these nanoparticles into a fleet of microscopic delivery drones for medicine.
The whole process is kind of like a three-step special ops mission. Okay, step 1. You coat these nanoparticles with whatever medicine you need to deliver and then introduce them into the bloodstream. Step 2. You take a powerful focused magnet and place it on the outside of the body, right over the target area, say a tumor. The nanoparticles, being magnetic now, are pulled directly to that one spot. And then step 3, you just turn the magnet off. The particles immediately stop being magnetic and release their medicine, exactly where it needs to be and nowhere else.
So you can see how this process is just a fundamental shift in how we can approach medical treatment. It's a game changer. So let's talk about the future of nanomedicine and really get into why this tiny tech is actually such a huge deal. Look, it all boils down to one word: precision. Just imagine chemotherapy that only attacks cancer cells, leaving all the healthy cells completely untouched. Or think about antibiotics delivered directly to a really stubborn infection that's deep in your body. What does this mean? It means way more effective treatments with way fewer side effects. I mean, that's the revolutionary promise here.
And that leaves us with a pretty mind-bending final thought. We've seen how this technology can completely change medical imaging and drug delivery, but just think for a second, what else could we control with a perfect, microscopic on-off switch that works inside the human body? The possibilities there? Well,
They're really just beginning to unfold.